Folks, we're back at it, and in the last video I preempted you and I said that in this video we're going to talk about lactams. What is a lactam and how do we name a lactam? Well, lactam, like I said before, the AM is going to come from the word amide, and an amide is a carbon double bond O with a nitrogen. Alright, so there's our functional group that we need to focus on when we name these structures. And just like lactones, lactams are cyclic amides. So that nitrogen can participate in a ring, just like the oxygen can participate in the ring. So let's think about how we named lactones. What do we do? Okay, well, we went to the ring structure, and this C double bond O, well, we said that was the first carbon, didn't we? We said that was spot number 1. And then, because we are focused on the amide, we went to the oxygen. That was the next carbon in line with the IUPAC name. That's the key, with the IUPAC name. So that means that this nitrogen is spot number 2. Well, how do we name it? If this was a lactone, and I just erased that nitrogen and I put an O there, what kind of name would you give me? Well, you would probably write down, well, that's spot number 2, and we would write down oxy, right? Okay, well, this is not an oxygen, so we can't use the same thing there. We have another prefix that we use. And the prefix for amide, or the nitrogen in the ring, is going to be aza. A-Z-A. Aza. So this is a 2-aza, not a 2-oxy. 2-oxy would be oxygen, and this is a nitrogen-containing ring. So we call this an aza. Well, we still go through and we name the cyclo group just like we did before with lactones. There's no difference. So it's still a cyclo. It's a cyclo what? Okay, well, 1, 2, 3, 4, 5, and 6 members in the ring. 6 members. So this is a hexane. But we drop the E and we add on O-N-E. Yes, I know. You didn't expect that, did you? 2-aza cyclohexanone. So the reason that we call this cyclohexanone with an O-N-E ending is because this is a one, which is a ketone. That C double bond O is still present, and I want to kind of give credit where credit is due. So this is a one ending, cyclohexanone. So the 2-aza represents the nitrogen in the ring. So let's take a look at another example. We've got a C double bond O with a nitrogen maybe, and this time it's going to be in a 5-membered ring. Okay, so how would we name this? There's no difference. No difference. Don't freak out on me. This is carbon number 1 with IUPAC. This is number 2 in the IUPAC system. So this is still a 2-aza. And there's a total of 1 and a 2 and a 3 and a 4 and a 5. There's still 5 there. So this is a cyclopentane. Drop the E and add O-N-E because of that C double bond O. So 2-aza cyclopentanone would be the name of that structure according to IUPAC rules. All right, let's do one more. We'll do a carbon double bond, and then we have a nitrogen, and off of these, let's do that. How would we name this one? Same thing. You've got this. Not a problem. You got it. No sweat. Well, this is carbon number 1. There's spot number 2. So this is a 2-aza. And how many things are in the ring? 4. Okay, it makes a ring. So it's cyclobutane. Drop the E and add one. 2-aza cyclobutanone. If this was 2-oxy cyclobutanone, well, that nitrogen would be split with an oxygen. Folks, that's how close lactams and lactones are to each other. So all of this reviewed IUPAC rules. Very similar, no major surprises. It was just the incorporation of how do we name the nitrogen in the ring. Now, you know as good as well as I do, common names are coming your way. So let's just go ahead and get those out of the way as well. We're going to have to talk about them. You know they're coming. So let's figure out how to name these using the common nomenclature rules. How did we do it before? Oh, well, we ended it with the word lactone. Well, we'll do the same thing here, but we'll end it with the word lactam. That's not surprising. Okay, well, in the lactone common name, what do? Well, we started here with carbon, and we said, hey, there's carbon number 1, and there's 2 carbons in the ring, and there's 3 carbons in the ring, and there's 4 carbons in the ring, and there's 5 carbons in the ring. And we only counted carbons. That's all that we did for the common nomenclature. So 5 carbons, the common name for 5 carbons is what? It's Valere. But we put a little O in there so we can say valerolactam. Again, it makes you sound fancy. Say it. Valerolactam. And then one more thing that we did when we named lactone. We'll do the same thing here with lactam. We said that this carbon, there's my major carbon, that's the header. So therefore, there's the alpha, there's the beta, there's the gamma, and there's the delta. So at the delta carbon, that is where that links up with the nitrogen. So delta valerolactam is going to be the common name for that structure. Almost identical to lactone. We did the same method that we used for lactone. The difference, we put lactam at the end, not lactone at the end. That's it, folks. That's all that we do. Again, nothing new is here. It feels new. It seems new. It seems different, but it's not. It's the same rules all over again. Just present it to you in a different way. It's like Taco Bell. You go through the drive-thru, I guarantee excuse me, I guarantee you that you're going to go through the drive-thru and you're going to order something and it will be some type of meat, cheese, bean, and a shell. It's just how are they going to present it to you? They're going to put it in a soft shell. They're going to put it in a hard shell. They're going to put it in a shell that they're going to press on and make a quesadilla out of. Or they're going to put it in a shell and make a Mexican pizza out of it. I mean, you name it, Taco Bell, it's the same menu items just slopped together in a different way. The same thing's happening here. It's the same stuff. It's the same rehash. We're just slopping it together and serving it to you in a different way. But it's the same taste. It's the same ingredients. That's why they make so much money. All right, so let's take a look at number 2. We do this the same way. This is a lactam. All right. Well, there's carbon 1, carbon 2, carbon 3, and carbon 4. There's 4 carbons in total. So we do count that carbon when we name this ring. There's 4 of them in total. So that makes this a butyr. And remember, we squeeze that little O in there. Butyrolactam. Otherwise, it looks a little weird. So butyrolactam is going to be the name. And just as before, there's my main carbon. This is alpha. This is beta. This is gamma. So at the gamma carbon, that's where the nitrogen is going to be located. So I'll put the gamma out in front. Gamma, gamma, do! All right, next example, down below, we do the same thing. This is a lactam. 1 carbon, 2 carbon, 3 carbon, and that's it. Just 3 carbons, and that's all that common name will refer to. 3 carbons. So the common name for 3 carbon chain is propion. But here it's kind of weird. You know, a lot of people will do propionolactam. Propionolactam. That's a little bit of extra effort. It's adding like an extra syllable in there. Propionolactam. So if you give me this, I'm going to count it correct. But actually, there's our O that we've kind of been squeezing into these names every time. So what you will find out is that for propion, we actually will just call this propiolactam. It's a little bit easier to say. We don't have that extra syllable in there. It's less letters that we have to write down, and people know exactly what we mean. So propiolactam, that's going to be the accepted name for that. And again, if you put the extra N and O in there, I will count it correct. It's not a problem with me. But keep in mind, it's not really proper for the common nomenclature system. So propiolactam. All right, well, if that's my header carbon, this is alpha, that's beta. So at the beta position, that is where that hookup happens to the nitrogen. So this is a beta propiolactam. All right, folks, so that is how we handle our lactam nomenclature. There is our example of lactams, which are cyclic structures that have a nitrogen in the ring. Very similar to lactones, except lactones have an oxygen in the ring. That's the major difference. One other thing I want to say is that very often I assume things, and here on these nitrogens, I did not write everything that's there, just like I did not write everything that's on each one of these carbons in the ring. We understand that hydrogens are going to be involved, meaning that we know that this is a carbon, and off of this carbon, we have 2 hydrogens to make a total of 4 bonds. The same thing's going to happen here. There's a carbon, and off of that carbon are 2 hydrogens that make 4 bonds. This carbon, well, there's 2 hydrogens that make 4 bonds. That carbon, well, there's 2 hydrogens that make 4 bonds. I did not write CH2, 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 CH2 in that ring. It's understood to be there. And that's the same reason that I did not focus on the nitrogen. So you need to understand that nitrogen in organic really prefers to have 3 bonds with a free set of electrons. Okay, well, nitrogen in each one of these cases of the ring, it has 2 bonds already. So the 3rd bond will come from a hydrogen. So there is a hydrogen at that spot. There's a hydrogen here. There's a hydrogen there. And then a free set of electrons will also follow those nitrogens throughout the molecules. So just kind of a throwback to Chemistry 251 when we talked about formal charges and how to calculate the proper number of bonds for each one of these things. All right. Now, we've got one more functional group left, I believe, and this is something called a nitrile. So let's just go ahead and knock it out of the park and kind of call it a day with the nomenclature system. So this will be probably our final functional group for this particular set of lecture videos as far as nomenclature is concerned. So nitrile is going to where we end up. What is a nitrile group? A nitrile group is a carbon with a triple bond to a nitrogen. The reason that we do this now is because we just got finished talking about nitrogen-containing compounds. So this is another nitrogen-containing compound, and this is what we call a nitrile. All right, so nitriles are kind of like alkynes, A-L-K-Y-N-E-S. They're very similar to alkynes. It is a triple bond that's involved in the molecule. It's very heavily densed with electrons. We see a very strong negative area that's there. Also, keep in mind, this nitrogen has 3 bonds here, but it also has a free set of electrons as well, because, like we said just a while ago, a few minutes ago, if you were paying attention, that nitrogen wants 3 bonds and a free set. Well, there's 3 bonds and a free set now. So we see this very polarizing in a way, because there's a lot of negative that's concentrated right there between the carbon and the nitrogen bonds. So this basically is going to be a functional group that's pretty important. We can do reactions with them. We can use these as nucleophiles and so forth in reactions. And we kind of seen some of that before in the substitution reactions and so forth. It was on that substitution chart that we talked about in Chem 251. Now, nitriles are very similar to everything else as far as the carbonyl world. So you're probably scratching your head and you're thinking, well, wait a minute, I thought this was a carbonyl lecture and you're throwing this carbon double triple bond into me. I know, it doesn't quite fit the model. But the reason that we do that is because nitriles are what we call carboxylic acid derivatives. Okay, so they are related. And there's not really a way that we can make a whole chapter on nitriles. I mean, we could if we wanted to stretch that information, but who wants to do that? Just give you the basics. What? Basics? I've set into this Chemistry 252 lecture series, and you're talking about basics, and now we're looking at like 18 different ways to name something. I know it doesn't feel like that sometimes, but it could be much worse. So these nitriles are carboxylic acid derivatives. They can react with water, all right? So this nitrile can react with water to form a carboxylic acid. So this is to come. We're going to get ready to talk about these types of reactions. But that is why they group them with the carbonyl family. That's why we name them now, because we're going to look at reactions using them. And those reactions will generate carboxylic acids. And we've already know how to name carboxylic acids, but we've not talked about how to name the nitriles that make the carboxylic acids. So this is the time that we do that. Very easy. Nothing surprising as far as this nomenclature system, meaning, let's do an example. CH3C triple bond N. How do we name it? Okay, well, you look at the longest carbon chain. How many carbons do you have? 2. All right, well, what's the name of a 2-carbon chain? Ethane. All right. There you go. You're at a start. Nothing surprising. You've used all the rules that IUPAC has told you so far. Now, how do you think we're going to name the nitrile group, that triple bond in? Well, not surprising, we're going to use the word nitrile. I told you, it's not rocket science. So I simply have to add the word nitrile at the end. So this molecule is called ethane nitrile. Notice I did not drop the E, because then there would be 2 N's that are together, and how on earth would you say something like that? It looks weird again on a sheet of paper. So we keep the E in the IUPAC nomenclature system, and we just add the word nitrile onto the end of this thing, and that's it. That's all that we got to do. Okay, let's do another. We'll take this benzene, and we'll do a carbon triple bond N. Okay, what do we do here? Okay, well, let's think. What did you do before? This is a ring system attached to a carbon that's somewhat involved in a double bond. It's a triple bond. How did we name the ring system? Oh, well, we named the whole thing. Why would it change? Why would it change with this? We do the same thing. So this is a benzene, and I'll write the word benzene down as a starting place. Now we've got to figure out how to handle that carbon triple bond in. You know, there was always a way that we did this. We typically started with this carbo unit, and that's what we would do here. There's no difference there either. It's just what else comes at the end of the carbo unit. And the C triple bond N is a nitrile. So carbonitrile group. So this is called a benzene carbonitrile. All right. Let's look at another example. CH3, CH, CH3 that points up. Then we have a CH2, a CH2, a CH2, a carbon triple bond N. All right. How would we name something like this? Use the rules. Use your words. You know what is going to happen. You know what I'm going to say. If you had to make a bet, what's the first thing that I'm going to say? Find the longest carbon chain, right? That's what we've always done. So carbon 1 and a 2 and a 3 and a 4 and a 5 and a 6. I could have went out to the left or I could have went up. It's still 6 no matter what I do. Keep it simple. Go straight across. So this is a hexane and a nitrile. A hexane nitrile. Okay, well, what am I leaving off? That doesn't include everything. What am I leaving off? I'm leaving off this methyl group right there. That's a CH3 hanging off of the main chain. How on earth do I name this? Well, you name it just like before. You count the carbons, folks. This is carbon 1 and carbon 2 and carbon 3 and carbon 4 and carbon 5. So this is going to be a 5-methyl hexane nitrile. That's how I name it using the IUPAC rules. All right, let's do one more, just to make you feel uncomfortable yet again. And this is a CH2, a double bond, a CH, a carbon, a triple bond, and an N. Oh, goodness gracious, what did he do to me again? Okay, well, don't freak out on me. What's your longest carbon chain? 3. And what do you call a 3-carbon chain? A prop. All right. So this is a propane, right? No, no, no. It's not a propane. There's a double bond in here. This is carbon 1, this is carbon 2, and this is carbon 3. So instead of a propane, this is a double bond, which means that it's a propene. Where does that double bond happen? Well, it looks like it happens at carbon number 2. All right, so 2-propene. If that makes you feel better putting it there, then put it there. But that's really the only place that it can go. There's no other option. If you left off that 2, we would know where it would go because it can't go on the first carbon. It already has 4 bonds. There's no way it can take a 5th. So the only option for the double bond is at spot number 2. So if you left it off, by luck, you get the points. But if you wanted to be prim and proper, you could put the 2 there to confirm, yes, the 2 goes on to the ene. Now, a lot of people will have issues with this because at the end of this name, I need to write the word nitrile. So does the 2 go to the ene or does the 2 go to the nitrile group? Well, nitrile will typically always happen at the end of a molecule if we're going to name it this way. But just to be safe, you could do a prop, just like we did in Orgo 251, and then split that up and put 2-ene to make sure that the 2 goes with the ene before you add the word nitrile. So prop 2-ene nitrile, or propene nitrile, or 2-propene nitrile would all work in this case. Now, you know what's going to happen next? It's going to be common nomenclature. So let's start with our very first example that we did together, and that's this CH3 carbon triple bond N. How many carbons? 2. What is the common slang for 2 carbons? Acete. A-C-E-T. Acete. Well, I can't and I shouldn't just write acetonitrile. That's silly. So we need something in the middle, and what do you think we're going to use? The world-renowned O. Acetonitrile. That is the structure for acetonitrile. A very common solvent used in a chemical laboratory. A very common mobile phase is what we call it in the instrumentation that we use in a laboratory setting. Acetonitrile is what everyone knows acetonitrile to be. We never really call it ethane nitrile. Even acetonitrile is printed on the labels that we order it from. So yet again, a common name is really outpacing the IUPAC name, and it's more accepted than the IUPAC name, which drives IUPAC crazy. But IUPAC is ethane nitrile, and the common name is acetonitrile. All right, well, what about the next one? This is something that we kind of saw back in the day with the benzenes. So this is what we called benzonitrile. It was one of those that I told you to memorize. So we did the same thing there. Benz, then add the O, and then add the word nitrile. All right, well, what about the next one? Okay, well, we do the same thing. this is a hexane nitrile. All right, so a hexane, a hex, common name is capro, right? Cape. So CAPRO, capronitrile. Well, we still have a methyl group there. That's not any different. We still use that in the common name. The difference is, though, I can't use the 5. Numbers should not be used in the common nomenclature system. All right, so there's my carbon. That means that this is alpha, this is beta, this is gamma, and this is delta. So this is a delta methyl capronitrile. That is how we handle this in the common nomenclature system. The one up here to the top, the last one that we did, this does have a common name. We're not going to use the common name. I would never ask you to do the common name because it's a little bit weird. It's one of those common names where you just kind of memorize it. It's like water. How did they get that name? Well, we really haven't talked about this yet, but it does have a common name, and this is acrylonitrile. But yet, I would never ask you to do something like that on an exam. I would just say, give me the IUPAC name, and I'll call it day, I call it an even, and I move on, and I grade the next question. All right, so there's the way that we handle the common nomenclature and the IUPAC nomenclature for nitriles, as well as the lactams that we started this video off with. So, if we go back and review, folks, this is what we're seeing. Carboxylic acids, acyl halides, acid anhydrides, esters, amides, and nitriles. For each one of these groups, we had a modified ending, and that modified ending was oik, acid, oil, halide, oik, anhydride. The esters were the OHs, the amides were amides, and the nitriles were nitriles. So there's a quick recap, not a full-length recap, but a very quick kind of touch base. Let's look at what we've did because there's been quite a bit. Again, sometimes it feels that way and sometimes it doesn't. But it is quite a bit of nomenclature to sink and absorb in. And the only way to get used to this is examples after examples after examples. All right, so there's kind of the story with the nomenclature system of the top 1 carbonyls. Now, what's up next are the reactions that all of these functional groups will do. They all behave in the same way, which is why we group them the way that we do. So don't freak out on me yet, but there are going to be quite a bit of reactions that we're going to have to get used to. And again, we'll cross that river when we get there. I'm just trying to build the bridge. That's all that I'm doing. So in the next video, reactions, the way it goes.